left with respect to y, look at the first term. With respect to y, 3x square is a constant. You wrote it as it is, and derivative of y is a 1. And second term, x log y, partial derivative of log y is 1 by y, and x is a constant multiplied to log y. Yeah, so that is why you get your second term. So this is about the function in two variables. Second, we took a little more complicated function and we said e power xy square plus y. This is an exponential function of two variables. So when you're differentiating with respect to y, derivative of exponential function is an exponential function, and the xy square plus y, if you're differentiating with respect to y, x is a constant, derivative of y square is a 2y, so 2xy is the first term, and derivative of y is a 1, so plus 1 is the second term. Again, partial derivative of g with respect to x is the exponential function coming as it is, and derivative of xy square treating y as constant, so derivative of y when you treat y as a constant is a 0, but xy square would be 1y square, so you have only this term. So this is what we did in the last class about the first partial derivatives. So we move on to the second partial derivatives. So yeah, the first partial derivatives of a function of two variables are themselves considered to be functions of two variables. You know that whenever you're doing the first partial derivatives, what you get is again a function of two variables. So which means you can do the job of differentiating them with respect to x again and with respect to y. So they themselves can be differentiated, because at every stage what you get is a function in two variables. Yeah, function in two variables. Right. Okay, so this gives us the four partial derivatives. Yeah, this gives us the four partial derivatives, which is del of del x, del by del x of del z by del x. That means the partial derivative of zx with respect to x. So that's a del square z by del x square. Then partial derivative of del z by del x with respect to y. So that is a del square z by del y del x. Just a representation. You're doing partial derivative of a partial derivative. So del by del y of del z by del y, which we can write as del square z by del y square. And this is a del by del x of del z by del y, which is del square z by del x del y. Okay, so just a representation, but one important note you need to make here is, if you check, you will realize that the two mixed partial derivatives are continuous and they are also equal. So when you check, yeah, a standard result says that these two are equal. Okay, so whether you differentiate, outcome is going to be the same. With respect to y is with respect to x, outcome would be the same. So this we will verify for a particular example, but this is the only note that we have for the second order partial derivatives. Anybody writing anything here? Yeah, mentioner doing it. Yellow boxes covering the screen. Which box is it? Check again. Which box is covering the screen? Check again. I can't see anything here. The chat box is there, but it's there on the extreme right. Now you're able to see that slide? Okay, go ahead. Doing it, otherwise we move on. Okay, nobody's mentioning or doing it. Okay, let me just move ahead then. Okay. Yeah. Today itself I'll do that. Slide completely neon. Covered with what? Where is this yellow box? I don't see a box at all. What about the others? Others also feel there's something here on the screen. Otherwise, I'll stop sharing and do it all over again. Have you finished? Yeah. Okay, same thing. Another way to denote the same thing. Yeah, you're familiar with both. Anything can come in the questions. It's just a representation that we're talking about. What is an fxx? Fxx is fx of what is an fyy? Partial derivative of fy with respect to fxy. This is a partial derivative of, yeah, y with respect to derivative of y with respect to x. Okay. Okay. So basically, since both are equal, it doesn't really matter. So we'll just write it del square by del x del y. This is right, actually. Partial derivative of x with respect to y. Partial derivative of fx with respect to y. Partial derivative of fy with respect to x. Okay, so notation is correct. Derivative of fx with respect to y, and this is a partial derivative of x. Okay, previous slide it wrote it in terms of z. Now you're writing in terms of f. Doing it. Yeah. Have you finished? Right. Yeah, we go back to the same example. The function which is in two variables. Now we find the first order derivatives and the second order derivatives also. Yeah. So start with the function on the two variables. This is the function 3x square y. Yeah, 3x square y plus x log y. When you're differentiating with respect to x, it is a 6x into y, and this log y comes as it is, derivative of x is a 1. when you're doing with respect to y, 3x square is a constant and derivative of y is a 1. And x log y, x is a constant and derivative of log y is a 1 by y, which we've done in the previous slide also. Next, we want to differentiate fx with respect to x. Look at this one. We are differentiating fx with respect to x. fx with respect to x. So go to fx and differentiate this with respect to x. So 6xy with respect to x is a 6y because derivative of x is a 1. And this term doesn't even have an x. So the derivative of a constant term is a 0. So fxx is 6y. Next, we'll try to find fyy, which is nothing but partial derivative of fy with respect to y. So first term has no y. So derivative of this term is 0. Second term, x is a constant, but derivative of 1 by y, all of us know, is a minus 1 by y square. So that is why we got a minus x by square. Any repeat till now? Any repeat till now? We just going back to fx and differentiating it one more time with respect to x, and fy we going there and differentiating it one more time with respect to y. So we get fxx and fyy. Yeah. Now we try to differentiate we want to get fxy term. So we decided we differentiate fx with respect to y. So go to fx, differentiate this with respect to y. Okay. So if you go to fx and differentiate this with respect to y, look at the first term. Derivative of y is a 1 and 6x is a constant. So that's why you got your 6x term. And log y, derivative of log y with respect to y is a 1 by y. So this is a derivative of fx with respect to y. Last one is derivative of fy with respect to x. So go to fy, differentiate this with respect to x. Derivative of 3x square is a 6x and derivative of x into 1 by y is just 1 by y because you're differentiating with respect to x. Yeah. So even if you understood, I'll repeat this again. All of us know how to get the partial derivatives. Yeah. All of us know how to get fx and fy. Okay, so this we have already done. Now we want to find fxx. So go to fx and differentiate it one more time because we want second partial derivative, second order partial derivative. So go to fx, differentiate it one more time with respect to x. So this term, if you differentiate one more time with respect to x, derivative of 6xy with respect to x is 6y. Derivative of log y with respect to x is 0. So that is why we got only a 6y. But what about fyy? Go to fy, differentiate it one more time with respect to y. Derivative of 3x square with respect to y. Sairaj, what is the answer? Derivative of 3x square with respect to y. Derivative of 3x square here with respect to y. What is its derivative, Sairaj? Derivative of 3x square with respect to y. Differentiating fy with respect to y. So 3x square with respect to y is a 0. And derivative of x into 1 by y with respect to y. Derivative of x into 1 by y with respect to y. X is a constant and 1 by y, if you differentiate, would you get a minus 1 by y square? So is fyy correct? Sairaj, is it correct? Yeah. Okay, so fxx and fyy know. Now we want to find fxy. So we go to fx and we differentiate fx with respect to y. We go to fx and then you differentiate fx with respect to y to get your fxy. Yeah. So go to fx, differentiate this with respect to y. Derivative of 6xy with respect to y is a 6x. Derivative of log y with respect to y is a 1 by y. So that is about fxy. Next, we want to find fyx. Derivative of fy with respect to x. So partially differentiate fy with respect to x. Yeah. So that would mean go to fy, differentiate with respect to x, 3x square derivative with respect to x is a 6x. Derivative of x into 1 by y with respect to x is a 1 by y. So that is why we got fxy and fyx. And are they equal? Are they equal? That's the note we mentioned earlier. Fxy, is it always equal to f by x? So we have verified that note is true, that for this function or every function in two variables, fxy will be the same as fyx. Anybody doing anything? Just mention doing it. Okay, I don't see her doing it. I'm assuming you finished. Yeah. Okay, this is also a function. Quickly check whether the answer is right, and if it's yeah, confirm the answer. If answers are right, we'll move on to the next slide. You verify for yourself whether the answers are right. Yeah, many of you are confirming that the answers are right. Anybody wants me to explain anything here? Mention. Or anybody doing it? Mention doing it. Otherwise, I move on. Okay, I don't see her doing it, so I'm assuming you finished this. Okay, this is the slightly complicated one. Yeah. We have a function in two variables, which is an exponential function. Okay. Quickly check whether fx is right. Derivative of exponential function is exponential function, and derivative of xy square with respect to x, is it a y square? Check whether fx is right. Derivative of an exponential function is exponential function, and xy square with respect to x, do we get a y square ahead? Yes. Is fx right? Okay. What about fy? Fy is you're going and differentiating f with respect to y. Derivative of exponential function is an exponential function, and derivative of xy square with respect to y, is it a 2xy? Xy square with respect to y, because x is a constant and you're differentiating y square with respect to y. So do you get a 2y? So fx and fy are right. Now we need to check what is fxx and fyy. Okay, fxx and fyy. Go to fx and differentiate it one more time with respect to x. So exponential function derivative is an exponential function, and derivative of xy square with respect to x, do you get another y square ahead, and does it become a y power 4? Confirm or mention a repeat there. Yeah, so you're saying it's right. Then we move on to, yeah. fyx. Okay, we'll move on to fyx. He's doing the fyy separately here. Or let's just finish fyy. Yeah. What is fyy? Fyy is partial derivative of fy with respect to y. Fy with respect to y. Now, can you see its product rule will come into picture? Look at this carefully. When you're differentiating this with respect to y, can you see that there is a function of y ahead and a function of y here also? There is an exponential function and a y ahead. So that means we have a product rule. So 2x we have taken ahead and then apply the product rule on the remaining terms. Okay, 2x is a constant that we're writing ahead, and then you differentiate just the y e power xy square. Okay, this will differentiate. Now, if I apply product rule, derivative of y is a 1 and e power xy square comes as it is. Next, e power xy square comes as it is. Yeah, and derivative of y is 1, e power xy square came as it is. Next, y came as it is, and derivative of e power xy square is e power xy square into derivative of xy square with respect to y, which is a 2xy. So therefore, exponential function is common in both the terms. He's taken it ahead, and then you can see a 1 is left of the first term, and the second term it's a 2xy square which is left. Okay, any repeat for an FYY, mention it, please. Those of you who want me to explain FYY, mention it. We'll move on to FXY and FYX. The repeats, I'm assuming you've understood. Next, we find what is the fyx. Okay, fyx is derivative of fy with respect to x, fy with respect to x. So go to fy, differentiate this with respect to x, and tell me what you will again have product rule. Will if you're going to fy and differentiating with respect to x, is there product rule coming there? Yes, okay. So what is the constant which will go ahead? A 2y will go ahead, and then you have an x into e power xy square. So again, you will do the same thing. Whatever you've done here, the same thing, you will apply product rule and confirm to me whether this is what you will get. Apply product rule on x e power xy square and tell me whether this is right and fxy is also right. Take 2 minutes time, check for yourself. It's not correct, then I will repeat again. Yeah, sorry. I had muted myself and I forgot I'll mute myself. Yeah. Any anybody who wants me to explain any of these, any of the second partial derivatives, mention it. Only the fxx came without any product rule. The other three we had used the product rule. Yeah, the other three we had used the product rule. And again, we have verified that fxy is the same as fyx. These two are the same. Yeah. Any of these second order partial derivatives, if you want me to explain, I can explain. If you're finished, we'll move ahead. Anybody doing it, mention doing it. Okay, I don't see her doing it, so I'm assuming you finished. Let's move on. Yeah, this is a question which I will come to later on. I will. Yeah, are you able to see the screen? Right. Okay, the same note which we mentioned earlier that the second order partial derivatives. Yeah, it is independent of the order of differentiation. Independent of the order of differentiation. Same thing. What we wrote earlier, we mentioning here. fxy is the same as fyx. Take a function tan inverse y by x and quickly find fxy and fyx and check whether they're equal. Tan inverse x by y. Hurry up. Your function is a tan inverse x by y. Find fx, fy and verify whether del square x del y is the same as del square fy del y square. Okay, let's start with partial derivative of f with respect to x. Tan inverse derivative is 1 upon 1 plus function whole square. So 1 upon 1 plus x by y whole square, and derivative of x by y with respect to x is just a 1 by y. Now you can take a common denominator in the denominator. So a common denominator in the denominator gives us an x square plus y square in the denominator, and this y square goes to the numerator. So we have a y upon x square. Confirm whether this is right, fx is right. Repeat if you haven't got it. This is right. What about fy? Do the same thing. This time you differentiate with respect to y and check and simplify and see whether you're getting this answer. Anybody doing it, mention doing it. Otherwise, we'll. Yeah. Those of you finished fx and fy, try to find fxy and fyx. That means you go to fx. Yeah. You go to fx and differentiate that with respect to y. Differentiate that with respect to y. You would have quotient rule coming. Would you have quotient rule? Or you can proceed with the product rule also. And then those of you finished an fy, go ahead for fyx, which is nothing but partial derivative of y with respect to x. Partial derivative of f with respect fy with respect to x. This is fy with respect to x. This is fx with respect to y. Use quotient rule, product rule, whichever, and just give the final answer. Tell me whether both are equal, fxy and fyx are equal. Yeah, okay, Pallavi's confirmed that they are equal. Yeah. Arpan, are you saying fxx and fyy are also the same? Fxx and fyy? Okay. Yeah. Yeah, it need not be the case for every question, maybe only for this one. Some of these questions yeah. We move on to the next slide. Okay, Maria saying they're not equal, one has a negative sign. Okay. What about these? These are the answers that you got. Quickly check whether these are the answers that you got. This is your, yeah, fxy is this. Okay, because you're differentiating fx with respect to y. So fxy is this. And this is your fyx, and check whether the answers are right. And Arpan says fxx is the same as fyy. Yeah, you can check that too. Those of you finished. Is fx is the same as fyy. Yeah, some of them are confirming they're equal. Maria, where is that negative sign? Is a negative sign missing here, Maria? Okay. They're not equal, Arpan, these two? Yeah, he says fx6 is minus of fyy. Okay, anybody on this slide doing it? Mention doing it if you've reached till here. Anybody wants me to explain anything here at this second derivatives, mention it, otherwise I'll move on. Pallavi is saying no extra negative sign came, both are equal. fx6 and fyy. Okay, I don't see you doing it, so I'm assuming you finished. Let's move on. Yeah, this is an interesting function. Your function in two variables is an x power y and a y power x, x power y and a y power x. Okay, so this is our function x power y and y power x. You're differentiating with respect to x. So when you're differentiating with respect to x, y is a constant. So would y come ahead? Y into x power y minus 1, because x power 7 is what? 7 into x power 6. So x power y is y into x power y minus 1, because y is a constant. Then is a constant raised to the power 6. So what is the derivative of a power x? Derivative of a power x is a power x log a. So derivative of y power x is y power x log y. Okay, here y is a constant. So derivative of a power x is a power x log a. So here y is a constant. So in place of a, we putting a y and we're writing, yeah. This is the derivative of a power x. So here, y power x log y. So that's about fx. Next, we want to find fy. To find fy, go to the first term. Y is a constant and it's an x power y. So he's doing an x power y log x with the same formula. And y power x by, because x is a constant, you get derivative to be x into y power x minus 1. Is it a clear or is it a repeat? Is it a clear or is it a repeat? Yeah, constant as the base, constant as the power makes a difference there. Constant as the base and constant as the power. As the power, you just do the normal differentiation of how you handle an x power 7, x power 10, and so on. But a constant raised to the power x, the formula is a power x log a. And now you need to check your fxy and fyx. Quickly confirm to me whether they are equal. Fxy and fyx. Remember, you might have product rule, you might have a lot of terms coming. Don't try to take anything common out, keep them separate and just see whether your fxy is the same as fyx. So what is the derivative of fx with respect to y? Quickly confirm to me whether these are the four terms that you will get. Don't try to do this common out thing. But now just leave it, keep it as it is. Yeah, confirm, one of you confirm that this equation is right. Derivative of fx with respect to y. Anybody wants me to explain the derivation of fx with respect to y? Okay. Anybody on this slide, anybody who's not reached here, mention doing it. Otherwise, I move on to the next slide. Okay, so nobody's mentioning or doing it. I'm assuming you finished. Yeah. So fxy is the same as fyx, and conclusion is both are equal. Yeah. Conclusion is both are equal. fxy is the same as fyx. Differentiate y with respect to x. Yeah, I will do that. Anybody on this slide doing it? Mention doing it. Otherwise, we just see what is there ahead. Let's see what we have ahead. Yeah, I will do that, Rishikesh. I'll do that. Right. Okay. So I don't see her doing it. I'm assuming you finished. fxy is the same as fyx. Yeah. Okay. So this is a slightly complicated function. X square tan inverse y by x minus y square tan inverse x by y. Functions are simple. Only thing is time taking. Will you check this for yourself? Will you check this for yourself? And he's not asking you to find both. He's just saying find one and then show that it is this. Okay, he's giving the answer and he's saying verify that. Yeah, yeah. fxy is this. fxy or fyx is this. You have to just verify whether. Will you complete this on your own? Just copy the question and finish it off yourself because answer also is given here. Find fx, partially differentiate with respect to y, or find fy, partially differentiate with respect to x. Do you want me to explain just the first part? Fy? Yeah, those of you can do it yourselves, can leave. Anybody who wants me to explain the derivative of this one, first derivative, I will explain. If you've copied the question, just finish it off yourself.